Hello all. In the previous video, we dealt with the introduction of MCDM, that is multi-criteria decision making. We were dealing with the example of selecting the best mobile phone among all available alternatives based on various criteria like cost, storage space, camera quality, looks. There are certain issues in selecting the best. All criteria have different unit, like cost is represented in dollar, storage space in gigabyte, that is GB, camera quality in MP, that is megapixel. So we cannot compare cost with storage space or camera quality. Another issue is the use of linguistic term. We don't express looks or appearance of mobile in some unit. We say it's good looking or it looks excellent. Well, we can solve or resolve this issue by using a conversion scale. Here I have used a 5-point scale in which low corresponds to 1 and excellent corresponds to 5. Well, after substituting the numerical value, we get a decision matrix. In this, each value in each cell is called or known as the performance value. For suppose 300 is the performance value of the third alternative, that is the mobile 3, over the first criteria, that is the cost. Next, we have to categorize the criteria into non-beneficial and beneficial criteria. Non-beneficial criteria are those criteria whose lower value is desired. For example, cost. We desire to have a product with lowest cost. On the other hand, beneficial criteria are those criteria whose higher value is desired. For example, storage space, camera, looks. We desire to have more storage space and better camera quality with higher megapixel. In order to make all criteria comparable, we do normalization. In beneficial criteria, we divide the performance value in individual cell with the maximum value. Let me take an example. Here, I'll take the example of storage space. In storage space, 32 GB is the maximum value of the criteria. So, we'll divide the performance value of each cell with 32. Similarly, for non-beneficial criteria, we take the minimum value and divide it with the performance value of each cell, like this. There is a difference in both beneficial and non-beneficial. Maximum value takes the denominator, and in non-beneficial, the minimum value takes the numerator. We do the same for all other criteria. On solving, we will get a normalized decision matrix. Next step is to assign the weightage to the criteria. In this example, I have allotted equal weightage to all criteria. For me, all the selecting criteria like cost, storage space, camera, looks are equally important. It can vary person to person. For some selfie lover, camera will have a higher weightage. They may assign the camera a weightage of around 50 to 60%. One important thing to note here is the sum of weightage is always 100 or 100%. Convert the percent into number and then multiply the weightage assigned to each criteria with its normalized performance value. On solving, we get the weighted normalized decision matrix. Next, we add all weighted normalized performance value of each alternative to get a performance score. So we can see here on adding 0.2, 0.125, 0.1875 and 0.25, we get a performance score of mobile 1 as 0.7625. Similarly, we can obtain the performance score of all other alternative. Ranks can be allocated to mobile based on the performance score. Here we can say, based on the weightage assigned to each criteria, mobile 3 is the best alternative among all other alternatives as it is having rank 1. Even if mobile 3 is not available in the market, we can go for the next best, that is mobile 1, which is having rank 2. Thank you and have a nice day.